JSON stands for JavaScript Object Notation, but you can forget the technical name. JSON is simply a way to organize and store information that both humans and computers can easily read. It's kind of the universal language that allows different apps, applications, and different services to share data with each other. So like every time you fill out a form online, or maybe check the weather on your phone, or receive a notification from an app, JSON is generally the thing that's working behind the scenes for that. It's the format that carries your information from one place to another. So like when Spotify shows you a song recommendations, or Instagram loads your feed, they're generally using JSON to structure that data and present it to you. You can think of it as the shipping container of the digital world. So just like how shipping containers really like revolutionized global trade by standardizing how goods are packaged and transported, JSON standardized how data moves between different software systems. It doesn't matter if one application is built by Google and another one by Microsoft, AWS, or whoever, they can both understand JSON. Before JSON became widespread, every system had its own way of formatting data. So that really created a lot of chaos when you're trying to connect different services. You'd have to learn it for each service. JSON solved this just by providing one simple, consistent format that everyone agreed to use, pretty much. So it's now kind of the backbone of modern web applications, and especially APIs, or application programming interfaces. Understanding JSON becomes intuitive when you think about like a recipe card. A recipe has different types of information on it. It has the dish name, it has a cooking time, it has a list of ingredients, and maybe hopefully step-by-step instructions. Each piece of information has a label and it has a value. JSON works pretty much the same way. It organizes your information using labels that are called keys, and then values, which is the data. The recipe name, might be labeled title with the value chocolate chip cookies, and cooking time could be labeled duration, maybe with a value of like 25 minutes, something like that. So just like that recipe card can contain a list of ingredients, JSON can contain your lists as well. Your ingredients list in JSON would be an array, so it's a collection of items grouped together, and you can nest information, so having each ingredient include like both the item and the amount needed as well. The beauty of the structure is its flexibility. You can describe anything from a really simple shopping list to really complex business data using exactly the same basic format. So whether you're storing customer information, product backlogs, sensor readings, JSON just adapts to fit your needs while remaining really readable and just well organized. And the standardized structure just means that any app can understand JSON, and it can read that recipe card regardless of who created it. It just doesn't matter. JSON uses a few simple rules to organize the data. Everything starts with the curly braces, and they kind of act like a container. Inside, you put pairs of keys and values that are separated by colons. So keys are always in quotes, speech marks, and they're followed by the colon and then the value. Values can be different types. So text goes into quotes, speech marks, and then numbers don't need quotes, so you can just have the number itself. And you can use true or false for yes or no, 1 and 0. And then when you need a list, you use square brackets. So the strings or the numbers, whatever it is, they go inside the square brackets. And this is where JSON gets powerful. You can nest objects inside objects. So a person object might contain an address object, which itself contains street, city, postcode. And this creates kind of a hierarchy that mirrors real-world relationships between data. In NaN, for example, you see the JSON structure visually on screen. So when data flows between nodes, NaN will display it in an easy-to-read format with collapsible sections. And you can click through nested data without getting lost in the brackets and the commas. And the platform kind of handles the JSON formatting automatically, which is nice. So you can just kind of focus on the data that you want to use, not how to structure it, not worry about it. Commas separate each key value pair, except the last one, where you need to not have a comma. And that simple kind of punctuation rule is what makes JSON both human readable and machine passable. Now, reading JSON is like reading an outline. You start from the outside and kind of work your way inwards. The outermost braces show that you're looking at an object, and then each key tells you what type of information follows. So when you see square brackets, you know you're dealing with a list of items. A customer order in JSON, for example, might start with basic info like order ID and maybe a date at the top level. Then maybe you'd see like a customer object containing, say, name and email at minimum. And then an items array could list out each product with its own details like name, price, quantity, something like that. Payment information might be another nested object with maybe card details or billing address. And so when you're working with JSON in automation tools, you kind of just navigate the structure by following paths. To get a customer's email from an order, you'd follow the path, which is maybe order, maybe customer, maybe email. And this kind of dot notation makes it easy to reference specific points of data without copying entire blocks. And most modern tools now show JSON in a tree kind of a view where you can expand and collapse sections. In N8N, for example, when webhook data arrives or an API call returns results, you'll see this tree structure immediately. Then you can click on any value to use it in your workflow. You just drag and drop it. You don't have to do any manual kind of parsing, which is good. Colors often help as well. So strings can appear like in green, maybe numbers in blue, booleans in orange, stuff like that. This visual coding kind of makes the complex JSON structure much easier to scan and understand in a lot of UIs. Every major web service now uses JSON for their API. So when you connect, say, Stripe to your website, the payment data arrives in JSON. The structure is going to include things like transaction IDs, amounts, currency codes, customer details, payment status, and it's all going to be kind of neatly organized and labeled so that you can use it. Weather APIs return JSON, with current conditions, forecasts, alerts, things like that. Each forecast day is going to be an object like containing maybe like temperature, highs and lows, or precipitation charts, things like that, just weather descriptions in general. Location data will include things like coordinates, city name, time zone, just everything an app needs to show relevant information for whatever it is that it is trying to show. And social media platforms use it a lot as well. So you get Twitter posts that include the tweet text and author details, timestamp, like count, retweet count, any media attachments. Each piece of data has a specific place in the structure, just making it easy for different apps to display anything consistently. And then you can think about like e-commerce platforms. They're going to structure like product catalogs in JSON. Each product's going to have like a name, a price, description, maybe some image URLs in an array, maybe inventory levels and category tags, stuff like that. The standardization just it's going to let you like sync products. If we've got like Shopify, WooCommerce, or maybe your own inventory management systems, you're just going to be able to synchronize them back and forth. And the same JSON structure just works everywhere. It eliminates manual data entry and kind of reducing errors. In N8N, JSON is everywhere, but you don't often have to deal with it directly. When you're designing the workflow, you do. But when you connect like Google Sheets node to read data, N8N is automatically going to convert the spreadsheet rows into JSON format for you. You don't have to worry about it. Each row becomes an object with column headers as keys, and then the cell values as the data. So setting up a workflow that processes maybe like form submissions is going to show JSON in action for you. Your form tool sends that submission data as JSON to N8N's webhook, and you'll see fields like name, email, message, and they'll just be appearing there as like labeled data for you. And then you can just drag and drop those from those fields to other nodes. Maybe you're sending the email address to ConvertKit or something, or maybe you're going to create a task in Notion with the message content. The code node is really useful in N8N because it lets you transform JSON data when you need to. So you might want to combine like first and last name fields to just give a name field. Or you might want to calculate totals from line items, or maybe reformat dates. Even these transformations can use visual interfaces where possible, and that'll show you kind of the data changes in real time. And when connecting to APIs, N8N often handles the JSON formatting automatically for you. You don't have to worry about it. So you'll fill in fields, select options, and then N8N just constructs the proper JSON behind the scenes for you. Response data appears kind of passed and ready to use, and there's no manual kind of JSON manipulation required with that. And that abstraction just lets you focus on building the workflows itself, so that instead of you wrestling with data formats. The most common JSON error is syntax mistakes. So a missing comma or an extra bracket, or unmatched quotes. So in NaN, you largely avoid those mistakes because the platform generates valid JSON automatically. But when you do need to write it manually, the built-in editor is pretty good at showing up any kind of syntax errors immediately, but sometimes it might miss them. So empty or missing values can break workflows as well. Maybe like a customer record might not have a phone number, or an API might return maybe null for optional fields. So in NaN, you can use the if node to check whether data exists before using it. And you want to set default values for missing data just to keep your workflows running smoothly. Large JSON files can be quite overwhelming. An API might return maybe hundreds of records when you only need some specific ones. In NaN, the nodes usually include options to limit results, or maybe to filter data, or just extract just the fields that you need. So you might want to split out an array maybe, you might want to sort it, you might want to filter it based on different criteria. And sometimes different services can use different JSON structures for similar data. So one service might call something email, while another system says email address. So in NaN, you can use the set node, and that lets you like rename and restructure data to match what the service expects, which might be different to your system. And that flexibility really ensures that your automations are just going to work reliably across different platforms.